So I wanted to do a little explanation of the climate graphs, climate evidence reasoning, and tell you what location these biomes are actually in. So you got your graphs back, you had your thought on what it was and why it could or maybe was a Minnesota biome, but maybe couldn't be in Minnesota. So the first one, graph A, was a temperate deciduous forest, which can be found in Minnesota, but this data cannot be. So you'll notice the average temperature across the year is 12.8 degrees Celsius. If you compare that to Minnesota averages, degrees Celsius, these ranges 3 to 7, 4 to 7, and 2 to 5 are too low. So this habitat or this data is from an area where it's warmer than Minnesota. In fact, look at here's 0. So no month of the year is below freezing. So we know it is not in Minnesota. But if we look at the textbook ranges for temp and precipitation, the range, looking at our average of 12.8, does fit the ranges that are possible for all three biomes, right? Here, 12 would fit in here, 12 would fit in here. But then we look at precipitation. Precipitation throughout the year, if you add up the averages per month, your total annual precipitation is 103.6 centimeters. If we compare that to Minnesota, 84 at the top end, 81 at the top end, and 89 at the top end. This is above any of the ranges in Minnesota for precipitation, centimeters wise. So I had to convert to centimeters of what I was looking at to compare. And if we look at deciduous forest, it does have 150 as a top range. So in the textbook, we have deciduous forests that do have over 100. So we could conclude that it is a temperate deciduous forest. This one happens to be in Washington, D.C. So yeah, over to the East Coast and a little further south. So again, here is my claim evidence, or here is my claim and my reasoning for that. All right, climate graph B. On average, for temperature across the year, the lowest to the highest, given an average, a negative 0.9 degrees Celsius. Well, again, looking at the Minnesota ranges for temperature, 2 to 3, 4 to 7, 3 to 7. So a negative 0.9 is less than all of these lower ranges. So it's too cold for Minnesota. And if we look at precipitation is higher than Minnesota, but within the textbook ranges. So we conclude we've got a coniferous forest, a coniferous forest, and the precipitation fits both within the range. Total average precipitation of 53.2. If we go back to our evidence about Minnesota biomes, over here, 52, 53. So that precipitation could fit in the prairie, and it could fit coniferous forest. If we look at the coniferous forest range, 50-something centimeters per year fits in here and could fit in the prairie, but it's colder. And so we're going to lean toward coniferous forest. So dry and colder, which makes sense because coniferous forest further north in Minnesota. And then lastly, and so it is colder than Minnesota. This graph B is Ontario, Canada. All right, last biome. Climate graph C. Average annual temperature 15.5 degrees Celsius and precipitation 55.2 centimeters. Well, again, above zero all the months of the year, so significantly warmer than Minnesota. It is dry, relatively dry, and it does have a drier season. But what's also really evident here is the July and June and August. These months are the coldest. In Minnesota, these are the warmest months. So this graph, temperature graph, shows you that it's coldest over our summer months, which tells you it's in the southern hemisphere. This is below the equator, where the seasons are reversed. So we know it has a dry season. We know it's pretty warm most of the year. And so if we go back to our data, textbook data, prairie, 52 or 53 centimeters of precipitation fits the low range of the prairie. So it's getting close to being desert-like or temperate shrubland. But this is a prairie, a temperate grassland in Argentina. And so there you have it. Temperate grasslands. So these are all three Minnesota biomes. They just don't fit in Minnesota based on the climate that is shown, either due to the seasonal variation or differences in temperature or differences in precipitation. And that's that.